myself Dr. M. Prasad Reddy, working as Associate Professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering, Hyderabad. So in today's class, I am going to discuss resistance and Ohm's law. So before going to discuss Ohm's law, first we will know what is meant by resistance, what is the properties of resistance, how the resistance is going to vary based on the various parameters. Before going to introduce the resistance, so here I am going to introduce some basic symbols which are usually used in the electric circuits. So if you are taking any electric circuit, so it may consisting of the three basic things. So one is the source, another one is the load, and you will be having the conductors to connect this particular source and load. So usually if you are taking the electric circuit, what you are going to study, so here we are going to take the source as the battery. So if you are taking the battery, so here you can see the battery having two symbols here. So this is whatever the physical structure of the battery, and here you have the battery which you are going to usually represent in the electric circuit. On the other side you have the ground. So this is the symbol for ground. So and the other one resistor. So here you can see, so this is the symbol for resistor. Usually you are going to utilize in the electric circuits while you are going to analyze. But if you are taking the physical resistor, so that is going to look like this one. So these are the three basic symbols, so which are going to utilize usually in the electric circuits. And here if you are looking at the laboratory circuits, so how you are going to connect the circuit in the laboratory, that means, so here you have the EMF or source, and here you have the rheostat, and here you have connected the 2 meters, that is the one is the voltmeter to measure what is the amount of voltage applied to the circuit, and here you have the ammeter to measure what is the current flowing through the circuit, and here what is rheostat. So rheostat is like a variable resistor, and if you want to vary the resistance, so always you have to replace the resistance by the various values in the circuit. So to avoid that particular situation in laboratory practice, usually we can utilize the rheostat, that is a variable resistance. So by varying the position of that particular rheostat, you can get what is the various values of resistances. So this is the general circuit which is going to represent like a laboratory electric circuit. And here, so what is the resistance? So what is the property of resistance? So resistance is nothing but, so it is going to oppose what is the flow of free electrons. So that means flow of free electrons means electric current. So the resistance is going to oppose what is the flow of electric current through the circuit. So if you are going to place resistors in any electric circuit, so along the path of the current, so it is going to oppose what is the flow of electric current. And if you are taking the resistance of the various materials, so each material is going to offer the different values of resistances. So for example, here you can take the three materials, steel, copper and glass. So all these particular three materials are geometrically equivalent. So only the material is going to change, but geometry means the length of each material and the cross-sectional area of that particular material also same. And also the same voltage is applied across the three materials. So across these particular three materials, 4 volts battery is connected. So that means a potential difference of 4 volts is connected across this particular material. So because of this particular potential difference, so there will be a current is flowing through all the three materials. So if you are going to observe what is the current flowing through this particular each of the circuit, then the current flowing through this particular last circuit, that is having the glass as the material, so which is possesses very low value of current. Why? Because means the glass is the insulator, so that is having no free electrons within it. It is going to completely oppose what is the flow of electric current. So that means here the glass, whatever the circuit here, so this particular circuit having very low value of current or zero current compared to these two particular circuits having the steel and copper. So like that, depending upon the material, the resistance offered by the circuit is going to vary, and also depending upon whatever the materials connected in the circuit, the current flowing through the circuit also depends. And what are the various factors so that are going to affect the resistance? First of all, the length of the material. So if you are taking any conductor, suppose you can take the 1 meter conductor and 2 meter conductor. So here you can see, so if you are increasing the length of the conductor from 1 meter to the 2 meter, so you can observe that the resistance is increased from 1 ohms to the 2 ohms. The resistance value is increased from 1 ohms to the 2 ohms. So this symbol is ohms. So that is going to represent what is the units of resistance. So units of resistance is ohms. So if you are increasing the length of the conductor or length of the material, then the resistance also going to increase. Why? There is a increase in the resistance means, so if you are taking the particular length of the conductor, so there will be a collision takes place. That means, so the free electrons will be having some force. So because of this particular force, whenever some external EMF is applied, so there will be a bombarding of the electrons takes place. Because of that one, so there will be a lose in the energy of that particular electrons, which causes some heat within that particular material. So if you are taking the more length of the conductor, then the more collision of electrons takes place, so that there will be more resistance offered by that particular material. So that is, if you are increasing the length of the material, then the resistance of material also going to increase. The other factor is cross-sectional area. So if you are increasing the cross-sectional area from, so here, so this is the cross-sectional area is doubled from this point to the this point, and you can observe that the resistance of that particular material is decreased from 2 ohms to the 1 ohm. So why there is a decrease in the resistance? If you are increasing the cross-sectional area means, so if you are having the less cross-sectional area means, so the path for free electrons will be less. If you are increasing the cross-sectional area means, so there will be a path for flow of free electrons. Free electrons can travel very easily within that particular medium, and the collisions will be very much less if you are increasing the cross-section area, so that the resistance offered by that particular material is going to be less. So that means, so if you are increasing the cross-sectional area, the resistance offered by that particular material is going to be decreased. The other one, temperature. Suppose if you are taking the any material, so if you are increasing the temperature, so because of the temperature, there will be movement of electrons takes place within that particular material. So due to which there will be a increase or decrease in the resistance that depends upon the material type. So usually if you are increasing the temperature, there will be increase in the resistance. So here you can see, so this is the initial value of resistance. So at room temperature, now if you are increasing the temperature of that particular material, the resistance offered by this particular material is going to greater than whatever the initial value of resistance at the room temperature. The other one is the kind of material. So here you can see there are two materials. One is the copper and other one is the iron. So iron is going to offer more amount of resistance than copper. Why? Because means the copper is having the more number of free electrons within it than the iron. So that's why it is going to offer large value of resistance. So these are the four factors that are going to affect whatever the resistance of a material. One is the length, other one is the cross-section area, then temperature, then what is the kind of material or property of material. Then what is the resistivity of material? So resistivity is a property of material, so that determines its electrical resistance. So if the material is going to offer more resistivity means, so it is going to offer the more resistance. So if you are going to relate whatever the resistance with respect to the length and cross-sectional area, so we can write the expression as R is directly proportional to L by A, and we can write R equal to rho L by A. So where R equal to resistance, rho is the resistivity of material, L is the length of material, and A is the cross-sectional area. So that means the resistance is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area. And you can write the resistivity as rho equal to R A by L. So what are the units of resistivity? That is ohm meter. So ohm meter is the units of resistivity. And temperature coefficient. So just now we have seen, So if you are going to increase the temperature of any material, the resistance offered by that particular material is going to increase. That depends upon material. So if you are taking the copper, iron, glass or any other materials, so the change in the resistance is not same for all the materials for the same applied temperature. So suppose if you are increasing the temperature from 30 degrees centigrade to the 50 degrees centigrade, and if you are taking the various materials and you can if you are conducting a experiment, you can observe that so the change in the resistance in all the materials is not similar. So you may observe that the different materials having the different rise in the resistance for a particular value of rise in the temperature. So usually we can represent the change in the resistance as delta R equal to alpha R naught into delta T. So what is the alpha here? So alpha is temperature coefficient. So that depends upon what is the type of material you are going to take. Suppose if you are going to increase the temperature by 1 degree centigrade, then what is the change in the resistance of that particular material? That is called what is the temperature coefficient, where R naught is initial value of resistance, delta T is change in the temperature. So you are going to change the temperature from X to Y. So what is the difference between the X and Y? That is going to be the change in the temperature. And you can take a simple example here. So the resistance of copper wire is 4 milli ohms at 20 degrees centigrade. So now we are going to increase the temperature to 80 degrees centigrade. Then the temperature coefficient alpha is given, alpha equal to 0.004 per degree centigrade. Now we have to find out what is the change in the resistance. And here you can see, so the this is whatever the actual resistance, and delta T, that is change in the temperature, that is from 80 minus 20, that is going to be 60 degrees centigrade. Now what is the delta R? That is alpha R naught into delta T. What is the alpha? That is given as 0.004, and what is the R naught? That is 4 milli ohms, and delta T equal to 60. If you are substituting all those things, what is the change in the resistance? That is going to be 1.03 milli ohms. So because of the rise in the temperature from 20 degrees centigrade to the 80 degrees centigrade, there will be a change in the resistance of 1.03 milli ohms. So finally, the total resistance R equal to R plus R naught plus delta R. So that is going to be 5.03 milli ohms. So this is how we can relate this particular change in the temperature. So because of the change in the temperature, there will be a change in the resistance also. So the temperature coefficient alpha is not same for the all materials. So different materials having the different temperature coefficients that you have to observe. Then for explaining the concept of resistance, so here I am going to take a simple example. So that is generally what is the resistance here? So resistance is, it is going to oppose the flow of electrons. So usually we can measure the resistance in the ohms. And what is the loads? So loads means if you are taking the any electric circuit here, so this is the battery, and if you are connecting the bulb here, so this bulb is going to act like a load. So that means here, so without the load there is no flow of electrons. So if there is no load means, so there is no flow of electrons. So that particular circuit is going to act like a open circuit. So for that demonstrating that particular example, so here I am going to consider, so compare the resistance to crossing a garg. Garg means like a crossing a river. So if you want to cross a river from one side to the other side, so one side you have the cars, other side you have the parking place, and if you want to cross the cars or if you want to park the cars from this side to the another side, you require a bridge. So here the cars are going to represent whatever the electrons, and here open space between the source, that is going to act like a resistance, and bridges are going to represent whatever the loads, and without the bridge you cannot cross the river. So that means without the bridge there is no flow of electrons or there is no current. So that I am going to explain here. So this is the no load, it is going to offer the infinite resistance. So here you have the river and here you have the cars. So if you want to cross this particular river, compulsory you require some bridge over here. So if there is no bridge means there is no crossing of this particular cars from one side to the another side. So that means, so if there is open circuit, then there won't be any current is flowing through the circuit. That means, so this is like a open circuit in a electric circuit. So open circuit, there is no path for electric current to flow through the circuit, so that the current in the circuit is going to be zero and it is going to offer the infinite resistance. So that means no load means here it is going to offer the infinite resistance. Now suppose if you are adding small load here. So now if you are going to add the small load, then you can see here there is a crossing of vehicles from one side to the another side. So that means if you are providing a small path for electrons, so then the electrons are flowing from what is the negative terminal of the battery to the positive terminal of the battery, so that the electric current is flowing in a circuit from positive terminal to the negative terminal. So that means you have added a small amount of load, but still it is going to offer a high value of resistance. So higher the value of resistance, less the flow of electrons. So narrow the bridge here, there will be only less amount of cars can cross that particular bridge at a particular duration of time. So this is like offering a high value of resistance. So a small load provides a path for some of the electrons, not for all the electrons. Now if you have increased the load, so if you are increasing the load means the resistance is going to decrease. That means, so you are providing a more path for crossing the cars from one side to the other side. So that means there is a more amount of electrons flowing in the circuit. That means it is going to offer the less value of resistance. And if you are increasing the load further, then what is going to happen? So if the increasing the load further means, so if there is no resistance or low resistance, then there is a path for free electrons to flow from one point to the another point, so that here you can see all the cars can cross this particular point at a time. So here you can see, so if all the cars are crossing at a time, then there is a huge amount of traffic is going to take place. So that is not feasible, or it is not recommendable. And here you can observe that similar way. So if the circuit is short circuited, then there will be a huge amount of electric current takes place. So that means huge amount of free electrons is flowing from one point to the another point of the circuit. So that is, if that happens, what happened to the circuit? So because of this particular one here, in this particular area there is overloaded. So here you can see, so these vehicles are crossing each other. So that is going to be overloaded. So overloaded means if you relate it to the electric circuit, it is going to like a short circuit. So if the circuit is short circuited, then the huge amount of current is flowing through the circuit, so which is going to damage whatever the devices connected to that particular circuit, and it is not recommendable. So that's what in any electric circuit compulsory you have to offer some value of resistance, so that you can operate the circuit in a very convenient manner. So whichever the current you want, you can supply to the circuit by connecting some value of resistance in the circuit. And before going to explain Ohm's law, let's have a look at what are the various types of electric circuits are available. So there are basically three types of electric circuits here. So one is the series circuit, one is the parallel, and another one is the series and parallel circuit. So what is the property of series circuit? And if you are looking at the series circuit here, the current flowing through the circuit is same. So here the current flowing through the entire circuit is same at any point, at this point or at this point or at this point, the current flowing through the circuit will be same. And it is having only one path for current. But if you are taking the parallel paths or parallel circuit, the current having the different paths to flow through the circuit. So this is one path for current flow, this is the another path, and this is also another path. So there are three paths for current flow. But whether the current is same through all the paths or not, that depends upon what is the value of resistance connected in the parallel circuit. And also we have the series and parallel circuit. The combination of series as well as the parallel circuit, we can call it as the series and parallel circuit. So if you are going to study any electric circuit, so that may be the series circuit, or that may be the parallel circuit, or that may be the combination of both series as well as the parallel circuit. And here this is the Ohm's law. So in 1827, George Ohms conducted a small experiment in the laboratory by connecting this particular resistance to a source. So he is connected a resistance value of R to the source. Then he measured by changing the voltage source. He measured what is the current flowing through the circuit. So by varying the voltage, so to know what is the variation in the voltage, he connected one voltmeter across the voltage source, and also he connected one ammeter in series with the circuit. Usually we can measure the voltage across and we can measure the current in the series. And for the different values of whatever the voltage is, and he observed that there is a change in the current. So if the voltage is increased, then he observed that there is a increase in the current also. And finally he plotted the graph between the voltage and current for the various values, and he got the graph like a straight line passing through the origin. So that means, so for the relationship between the voltage and current is linear in a resistive circuit. And also he conducted the experiment again by changing the terminals of battery. So later he observed that, so he is going to get the negative values of whatever the voltage and current. So finally, for the two different ways, by changing the battery terminals, when he plotted, he got a graph in the first and third quadrant. So in both first and third quadrant, he got the graph like a linear curve. So that means, so for a similar amount, for a small amount of increase in the voltage, there is an increase in the current also. So that means here, so basically here the Ohm's law, so it is going to relate the three quantities, that is the voltage, current and resistance. So if you are going to increase the voltage, you can observe that there is an increase in the current, and even if you are going to change the resistance also, there will be a change in the current also for the fixed value of voltage. So finally, the Ohm's law gives you what is the relationship between the voltage, current and resistance. So according to this particular Ohm's law, so here whatever the voltage applied across a resistor, that is directly proportional to the current. So that is given by V is proportional to I. And here, so this is the usual statement we can use. At constant temperature, the voltage across the terminals of a conductor is proportional to the current flowing through it. So the constant temperature is very, very important here. So why? Because, so if there is a rise in the temperature of conductor, so there is a change in the resistance also. So for that particular cases, we cannot apply the Ohm's law. So whenever you are applying the Ohm's law, you have to consider the resistance of the circuit is constant. So at constant temperature, the resistance offered by the material also going to be constant. So that we can write it as V is proportional to I and V equal to IR. So where R is nothing but constant of proportionality, that is also called as the resistance. So what is the resistance that we already defined? So that is going to oppose what is the flow of electric current, or it is going to oppose the flow of free electrons. So by using this particular Ohm's law, that is V equal to IR. So if you know any two quantities, if you know the voltage and current, you can calculate the what is the resistance offered by circuit, or if you know the current and resistance, you know what is the voltage applied to that particular circuit. So that means, so you can utilize this particular Ohm's law in different ways. How we can utilize means, here you can see. So this is the Ohm's law triangle having the voltage, current and resistance. So if you want to find out the voltage here, so V equal to the product of these two. And if you want to find out the current, so that is the V by R. And if you want to find out the resistance, that is going to be V by I. So like that you can find out the voltage, current or resistance of any given circuit. And this is the simple example to demonstrate what is the Ohm's law. So here, this is the given circuit. So the circuit having resistance of 24 ohms and current of 5 amps. Now we have to find out what is the voltage applied to this particular circuit. So by using Ohm's law, that is V equal to I into R. So I is given, that is 5 amps, R is given 24 ohms. So if you are multiplying these two, you are going to get the 120 volts. So this is whatever the voltage applied. So this is the simple application of Ohm's law. So like that you can utilize the Ohm's law in any electric circuit to know or to find out what is the unknown quantities of either voltage, current or resistance. Then power dissipation. So what is the power dissipation? So whenever the current is flowing through a resistor, the resistor is going to get the heat. So based on the resistance offered by that particular material, the heat generated in the material is going to increase. So that means, so in most of the cases, instead of measuring the value of resistance instead of mentioning the value of resistance in the ohms, sometimes in a commercial value of resistors, so the value is mentioned in terms of the power dissipation also. So that means the power rating of the resistor usually used in the commercial applications. So based on if the power rating is 2 watts means, so you have to connect a resistor and operate the electric circuit in such a way that the power dissipation cannot be more than 2 watts. If it is more than the 2 watts means, what is going to happen means the resistor is going to burn, and in a similar way whatever the devices connected in the circuit also going to affect. So that is always you have to look at the power rating of that particular resistors also. So for a resistor, the power dissipation can be expressed by using the relation P equal to V into I. So V is nothing but voltage, I is nothing but current. And if you are utilizing the Ohm's law here, so as you know V equal to IR, if you are substituting this particular relation, you will get the I square into R. And also if you have the relation I equal to V by R, if you are substituting I equal to V by R here, you are going to get the power dissipation P equal to V square by R. By using all these particular three relationship, if you know either any of the two quantities, either the voltage current or whatever the current or resistance, or voltage and current and resistance, you can find out what is the power dissipation takes place in that particular resistor. So this is what is power dissipation in a resistors. And here you can see how the resistance is going to affect on current as well as the power, that is the watts. So for all these particular cases, the applied voltage is 120 volts. So if you are going to apply 120 volts across a infinite resistance, so then what is the power and what is the current? So as it is open circuit, the current is 0. So if the current is 0 means P equal to VI, so then power also going to be 0. And if you are taking the resistance is 1500 ohms, then if you are going to apply 120 volts, what is the current? So I equal to V by R. So you know the V, that is 120, and you know the R 1500. So you can calculate the current. So like that, if you are decreasing the resistance, then you can observe that there is an increase in the current and there is a increase in the power also. So that means, so if you are increasing the, or if you are making the resistance is 0, then there will be infinite amount of current will flow through the circuit, and whatever the power, that is also going to be very huge amount. So in that particular cases, what is going to happen? So there will be a tripping of that particular circuit. So this is not desirable in any electric circuits. So that's what you have to provide always some value of resistance in the circuit to operate the circuit in a very convenient and useful manner. And what are the limitations of Ohm's law? So far we are discussing about the resistance only in the circuits, and if you are taking the circuits containing whatever the diodes or whatever the transistors, so you cannot apply the Ohm's law. So Ohm's law you can apply for any circuit which is having the bilateral elements, that means so which are going to allow the current flow in either directions. But if you are taking the diode and transistors, so that are going to allow to flow current in only one direction. And also Ohm's law cannot be applied for nonlinear elements. So nonlinear elements means, so whichever the elements having the nonlinear characteristics, nonlinear VI characteristics, so for that particular elements, so we cannot apply the Ohm's law. So if the circuit containing the thyristors, so there you cannot apply the Ohm's law. Why? Because if you are plotting the VI characteristics of thyristors, you cannot get the straight line characteristics passing through the origin, rather than you may get the some other nonlinear shapes. So for that cases, you cannot apply the Ohm's law. And what are the applications of Ohm's law? So generally what you are going to do to increase the speed or decrease the speed of your fan, So you are going to use the regulator. So if you are going to turn your regulator, means that is you are going to vary the resistance within it. So depending upon whether you are increasing or turning right or left of that particular regulator, so there may be increase or decrease in the resistance. Accordingly, the current supply to the fan is going to increase or decrease. Accordingly, you are going to vary the speed. And also in voltage divider circuits or in series and parallel circuit, you can apply the Ohm's law to find out what is the unknown value of whatever the resistance as well as the currents. And also not only in electric circuit, in some other electronic circuits and some other instrumentation circuit also, you can utilize this particular Ohm's law to provide a necessary whatever the voltage drop in a circuit. So this is all about whatever the resistance and Ohm's law. In today's class, we have seen what is the basic symbols used in a electric circuit and what is the laboratory electric circuit look likes, and what is the resistance, what are the factors are going to affect the value of resistance, and we have defined the Ohm's law and how we can apply the Ohm's law to the electric circuit. We have defined with a small example, and also we have seen what are the limitations and what is the applications of Ohm's law. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.